This is section 4.5, exponential growth and decay modeling data. Now, these first problems in the PowerPoint, I'm going to skip over. I'll just talk about them briefly. I don't have any homework on these. They're useful for some majors, but most majors not very useful. This says the exponential model describes the population of a country, A in millions, 2 years after 2006. Use this model to find the population in 2006. If you're going into majoring in political science, going to government, then this would probably be an important thing to study. If you go into nursing, these probably wouldn't be bad questions to take a look at. Now, I do got these worked out in a YouTube video. Country's got a plan. What's going to happen after 20 years for the population? The population become too big for their country. You're gonna have people starving to death, so they gotta plan those things. I mentioned about China coming up with their weird policies back in the 80s, but they had to, because they were sitting there looking at the exponential growth and they had to do something. Whether they did the right thing or not, that can be debated, but they had to do something. Here in the United States back in the 80s, the big push was they even had a famous book on it that you're only supposed to have 2 children to replace the parents, no more than that. And that was a big push because they had these visions of us running out of food and so forth. Okay, here's another population one. Now, I say good for nursing too because, and I'm not very good with medical or life sciences in general, but when you have bacteria or viruses or whatever's in your body that's got an infection spreading, when it starts growing exponentially, that's not good. That means you're probably close to death. So what they'll do is give you mass infusions through IVs of medicine to knock it back. So they did have to deal with population growth when you're talking about the medical field. Here's another population growth. Another population growth. Now here it talks about artifact originally had 16 grams of carbon-14 present, decay model given by that, describes the amount of carbon-14 present, how many grams of carbon-14 would be present in 10,000 years. So this is carbon dating, where they can age something. So if you plan to go into archaeology, then probably wouldn't be a bad thing for you to look at that problem. Although I had an archaeology major one time, and he indicated that there's more advanced methods in carbon dating for dating something in terms of age. So. It's funny because we present this. This will tell us the how old something is, right? Carbon dating is what they use that for. But to come out better methods, which means this wasn't right to begin with, right? So that's always interesting. A lot of that's just kind of an estimate anyway. And half-life of the radioactive element plutonium 239 is 20,000 years. There's 20 grams of plutonium 239 initially present. How many grams present after 20,000 years, 40,000 years, 60,000 years? If you're going to major in nuclear science, you probably want to go watch this video, this part of the video. Most of us don't deal with plutonium, but I suppose if you want to figure out, I think we got a nuclear power plant out in eastern Kansas somewhere. If that melted down, how long before we could live there? So there's a lot of different things it could tell you. Makes good horror movies. What is that? Wrong Turn. Anybody watch horror movies? Yeah. Is it Wrong Turn where the radioactive have mutated them? People. Is it? I like those Wrong Turns. They're kind of stupid, but There's one where I think the hills have eyes or something like that, where they live underground. I like that one too. I like them all. Okay, here's more carbon dating, half-life, nuclear science, radioactive, radioactive. Okay, now here's what we're going to focus on. Now the problems we're looking here will use the same principles as those first problems, so it's not like you're missing anything. They're just a different application. And specifically, these deal with compound interest, which is something that most of you will probably have to deal with at some point in life. Whether you buy a house, car, go into debt, and your credit card, you'll deal with compound interest. Got two formulas. The key is whether it says continuous or not. If it does not say continuous, we're going to use A is equal P times 1 plus R over N to the NT power. If it does say continuous, then we use A is equal PE to the RT power. Now A is our ending amount, P is our beginning amount, R is our rate, and that's in decimal form. T is our time, and that's in years. And N is the number of times compounded per year. Compounded is a fancy business term, means calculated. Compounded, what that means is they take the interest and they put it back into the account. So it compounds, it builds. So that's why they use the word compounded instead of calculated. Now these problems revolve around giving you some of the information you have to solve for the missing variable. So let's take a look at number 12. Given interest being compounded monthly, principal is 2,000, time is 2 years, and rate is 3%, find the ending amount. As I'm sitting here reading this, nowhere does it say continuous. Since it doesn't say continuous, and we're talking about compound interest, then we're going to use A is equal to P times 1 plus R over N to the NT power. And let's write down what they give us. Given interest being compounded monthly. Now, compounded monthly gives us our N. N is the number of times compounded per year, so if it's compounded monthly, N is 12. Principal is 2,000. Time is 2 years, so T is 2. And rate is 3%. So R is equal to 0.03. Now we're going to plug in everything they give us and then solve for the missing variable. A we don't know. P is 2,000. 1 plus R is 0.03. Divide by N, which is 12, raised to the NT power. So that's 12 times 2. Before you plug in your calculator, it's a good idea to do the calculation in the exponent first, if you can in your head. 12 times 2 is 24. You can plug it into the calculator all at once, but you'd have to put parentheses around the exponent to get it to work, unless you got a newer TI-4. So I got 2,000. Beginning parentheses 1 plus 0.03 divided by 12. Close parentheses, caret 24. And then enter. And now it would give us our answer. So 2,123.51. I may have mentioned, I don't remember. Again, old, I don't remember things. But my wife and me had our biggest fight over compound interest. Did I mention that in here? Don't think so? Okay. Big fight. She started us investing age 35, I think it was, which is too late. You can't start that late and have it ramp up. Well, a little bit at the end, but yeah, if I ever can't teach, I'll probably be working somewhere else. Won't be enjoying my golden years like I should. Well, she started us investing. She asked me if I wanted to go down and talk to the financial planner. And it's like I'd rather use a Japanese suicide sword myself than go down and hear about finance. I don't get excited about business. No offense if that's your area of expertise you want to go into. Everybody has areas they enjoy. So I said no. She went down there. She came home all excited. Said, David, I have fantastic news. We're going to be putting, I forget how much she said, $1,000, $2,000 in over this year, and we'll double our money at the end of the year. And I can't help myself. I'm sarcastic. Nastiness comes out of me sometimes. And I said, well, we need to get a different financial planner. And she said, what do you mean? I said, we need to find one that isn't dealing drugs. You can't double your money in a year's time, especially conservative people like we are. You know, we're not very risky. We don't go with the high risk stocks and so forth. And like I said, I didn't say it pleasant. I was nasty how I said it. I was very wrong. I was correct math wise. There was no doubt about that, but I was very wrong. I could have said it very lovingly. I could say, honey, I think you might have those numbers incorrect. You might want to go talk to them again. Big fight. Of course, I was right, but I was very wrong. I'll never forget that biggest fight of our marriage. Okay, number 13. Blah, 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 blah. Nowhere do I see the word continuous. Your first reading on these compound interests should be to see if you see the word continuous. So that means we're going to use that A is equal to P times 1 plus R over N to the NT power. So now I read it closer and identify what's given. Given interest being compounded quarterly, that means 4 times a year, so N is 4. Ending amount, which is A, is 5,000. Time is 5 years, so t is 5. And rate is 4%, so r is 0.04. Remember, it has to be in decimal. Then it says find the beginning amount, the principal. So we're wanting to find p. So I'll put in everything that's given. This would be, we want to end up with $5,000 at the end. We're going with an account that pays 4%, about a quarterly. And n is 4 times t, which is 5. So we want to leave it in there 5 years. After 5 years, we want to have $5,000 we can buy a boat. Used boat. First off, although I could simplify that 0.04 divided by 4 pretty easy, the only one I'm concerned about is the 4 times 5, which is 20. Now we need to solve for p. Now this 1 plus 0.04 divided by 4 to the 20th power. If I plug that in my calculator, that'll just give me a number. Don't know what it is, but it's a decimal number. Remember, when we solve problems where we had a number besides a variable, we divide both sides by that number. And that's what we'll do here. We'll divide both sides by this number. So we got 5,000 divided by 1 plus 0.04 divided by 4 to the 20th power is going to equal to p. And that gives us 4,097.72. So if we're going to leave our money in there for 5 years and we want to end up with 5,000 at the end, then that's how much we'd put in initially. Now, none of this has anything to do with putting in like monthly. So realize when you see these amounts and you think, well, that isn't very much of an increase in 5 years' time. No, it isn't. But again, the idea of a retirement plan or anything like that is you're putting in monthly and it accumulates and grows exponentially. Okay, number 14. Again, my first reading should just be to skim it, look to see if I see the word continuous. No word doesn't say continuous, so we're still doing the same formula. Now I'll go back and read it closer and write down what's given. Given interest being compounded daily, so n is 365, we ignore leap year. Ending amount is 6,000, so A is 6,000. Beginning amount is 5,500, so P is 5,500. Rate is 7.2%. R is 0.072. And wants us to find time. Okay, so we ended up with $6,000. We started with 5,500 at this rate, compounded daily. We wonder how long do we leave the money in the account. So I'll put in everything that's given. 6,000 equals 5,500. 1 plus R, 0.072, divided by 365. Raise the NT power. So I got 365T. Now this is an exponential equation because we got a variable in the exponent. And if you remember, our test for solving an exponential equation says get the part of the variable and the exponent by itself on one side. It's not quite by itself. We got 5,500 in front of it, so we'll divide both sides by 5,500. Our next step, you could simplify this fraction if you wanted to, but there's really no need because you're going to end up putting in the calculator anyway. Our next step is to take ln of both sides, natural log. So ln of 6,000 over 5,500 equals ln 1 plus 0.072 divided by 365, 365 t power. Now our third step in solving exponential equations is to use properties of logs to get the variable out of the exponent. Remember, if we have log of something to a power, we can take the power and put it on front of the log. And then our last step is to solve for the variable. In this case, it's t. Now there's a 365 in front of it. So to get rid of that 365, we'll divide both sides by 365. Now after the t, we have natural log of 1 plus 0.072 divided by 365. I don't know what that's equal to, but if I plug that in my calculator, that'll just give me a number. Just like how we get rid of the 365 here, to get rid of this, we divide both sides by that number. Now, important part of plugging this in your calculator is since we have such a complicated bottom part where we got a number of times in log, we have to put parentheses in it when plugging in our calculator. So, natural log of 6,000 divided by 5,500 divided by, beginning parentheses on the bottom part, 365, natural log 1 plus 0.072 divided by 365. You don't need the closing parentheses at the very end unless you just want to put them. Then enter. So that'd be 1.21 years. Okay, number 15. I'm sitting there reading it, and nowhere does it say the word continuous. So that tells us which formula to use. And we'll write down everything's given. Given interest being compounded semi-annually. Now, semi-annually is a weird one. It means n is equal to twice a year. There was a, it's funny because the geniuses like they are, supposedly, would not even have to ask that question. But there's one where they, on the Big Bang Theory, they buy a time machine. Anybody see that episode? Yeah. And they're debating, then like, moving it from one apartment to another, to their one house to another, whatever it is. And they're talking about bi-monthly. And And Sheldon's like making a big distinction about, well, do you mean twice a month or every 2 months and so forth? Well, they wouldn't even have to ask that. But to avoid issue, they use semi-annual. So that means twice a year instead of every 2 years. Yeah, you don't see many math references in TV shows. Okay. Ending amount is 7,000, so A is 7,000. Beginning amount is 5,000, so P is 5,000. And time was 30 years. And want to find out what the rate is. Now, not necessarily in terms of this formula, but this is not an uncommon question people have in life. My wife comes to me, well, she doesn't come to me very much on it anymore since I didn't help her. But she's selling Mary Kay now, and they take amounts out for each transaction. And at first she's just off the deep end on it. She says, well, look at this amount they took out. They took out this, and I said, well, they're not going to process your credit cards for free. You know, they charge you amount. And then she's trying to ask me what percent are they taking out? And that's, and that's what, this question would revolve. What is the percent? And I told her I didn't know how to figure it. I did know how to figure it. I just didn't want to do the mathematics at home. Too many episodes of Family Guy to watch. But that's not an uncommon question you might have. It's just like, what are they charging me? Now, the truth of the matter is they publish that on their site. So if she went out to their site, she could find they charge 2 point whatever percent. Okay. So let's plug in everything we're given. A is 7,000. P is 5,000. 1 plus R. R is what we're trying to find. N is 2. Raise the NT power. 2 times 30. Well, before I do anything, I'm going to take 2 times 30, which gives us 60. Now, our goal is to get R by itself. And so a good start is to divide both sides by 5,000 and get rid of that 5,000. So 7,000 divided by 5,000. 1 plus R over 2 to the 60 power. We saw these back in, chapter 1. So it's been a while. But I can write the 60 as 60 over 1. Put it into fractional power form, rational exponents. To get rid of this rational exponent, I'm going to take both sides the reciprocal of that. And by the way, I'll simplify this a little bit, because if you got 3 zeros on the end here, 3 zeros on the end here, the zeros cancel. And I'm taking both sides the 1 over 60 power. Normally, if we had an even power to begin with, we would worry about putting a plus or minus on the other side. But since we're dealing with rate, a negative rate doesn't make much sense. Now, when I raise it to the reciprocal over here, the 60s would cancel and the 1s would cancel. And we'd be left with 1 plus R over 2. Now we're trying to get R by itself, so I can take the 1 over, so it becomes a negative 1 plus 7/5, the 1 over 60 equals R over 2. Multiply both sides by 2 to get rid of that fraction. And that it'll give us our R. Important part in plugging this in your calculator, since we have more than a single number in our exponent, we have to put parentheses around that exponent when we plug it in. Okay, 2 times -1 plus 7/5 caret, and then parentheses around the exponent, 1 divided by 60. And that gives us 0.011247, so forth. That's in decimal form. To put in percent form, you'd move your decimal point 2 places to the right or multiply times 100. So it'll be 1.12%. Questions on that formula? Okay, so this next formula, or next problem, blah, 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 continuously. So this one specifically tells us is compounded continuously. If you have the continuous wording in there, they want to use the PERT formula. Which is the easier one. Okay, given interest has been compounded continuously, principal is 2,000, so P is 2,000. Time is 2 years, so T is 2. And rate is 3%, so R is 0.03. And it says find the ending amount. So we're trying to find A. Again, we'll plug in everything that's given. So that's 2,000 e to the r, which is 0.03, times t, which is 2. These are challenging to put in for some people. Seems like when this one's on the test, a lot of people miss it because how they put it in. If I do 2,000, now how I get e, remember, is second ln, second natural log. It puts a e, puts a caret, puts the beginning parentheses. When you put this in, you want to make sure you do not put any extra parentheses in. It put the beginning parentheses there for me. I didn't put any other ones in. And then I put 0.03 times 2. And then enter. And that'd be our answer. What people will do when they plug in their calculator, which is incorrect, they'll do 0.03, and then they'll do a closing parentheses and then beginning parentheses 2, which makes sense because you've been told from the beginning of time that parentheses next to each other indicates multiplication. But it gives you about double the amount because of the order operations. Please excuse my dear Aunt Sally. Please, nothing to do inside parentheses. Excuse, it does the exponent first. So it does the e to the 0.03 first, not 0.03 times 2 first. So that's why you can't put any extra parentheses in. The first technique is the correct way. And they design test banks such that they anticipate the most commonly made mistake. And this second answer is always one of them that's listed. So people get one of the answers, they think, oh, I did it right. That's just how they design test banks. Okay, number 17. As I'm sitting there reading through it, it says continuous. So we're going to use our part formula. Given interest being compounded continuously in the amount is 5,000. So A is 5,000. Time is 5 years, so T is 5. Rate is 4%. R is 0.04. It says find the beginning amount. So they want us to find P. So plug in everything we're given. A is 5,000. P is what we're trying to find, so I'll leave it alone. E to the R is 0.04, times T, which is 5. Now we're trying to get P by itself. This E to the 0.04 times 5, if I plug that in my calculator, that just gives me a number, a bunch of decimal places. So to get the P by itself, we're going to divide both sides by this number. So we'll take 5,000 divided by E to the 0.04 times 5. So 5,000 divided by E. Again, key is do not put any extra parentheses in here. And that'd be 4,093.65. Now, just thinking about what that's saying we're going to put $4,000, roughly $4,100 in, let's say. We're going to leave it for 5 years, and we'll have $5,000 at the end of that 5 years. This is why I knew you can't double your money in a year's time. Just because I know the nature of exponential growth. Doesn't occur that fast. Now, the retirement plan was such that we're going to be putting in money every month, but you still can't double your money in a year. It'd be fantastic if you could, wouldn't it? There's some kind of riddle or something like that, where the person wanted back in ancient times, and they said that they wanted to give them a certain amount of money. And they said, no, just put like a penny on the first square in a checkerboard, and then keep doubling the money. So you got 1 cent here, and then you take the previous value, you're doubling your money, so you're multiplying it by 2. There's 64, and you see then you go from 1 penny to 2 pennies. And there's 64 squares on a checkerboard, or chessboard, I think. It's been a while since I played it. If I fill that down to 64, assuming I can get down there, I'm going past it. There it goes. So initially it went from 1 penny to 2 pennies and 4 pennies and 8 pennies. Doubling your money doesn't seem like it amounts to very much. But then when you get down to the 64, let's see, million, billion, trillion. Don't know what's after trillion, gazillion, I don't know, 92 gazillion dollars. That shows you the power of doubling. So this is the way things grow. They grow as slow to begin with and then take off. Okay, Fairly exciting if you're it's your retirement plan, you're thinking about the future. Not very exciting if you start getting in debt with credit cards and so forth, because it does take off on that side too. And you're owing so much, you finally declare bankruptcy. I almost got to that point. My wife's a financial wizard. She got us out of that. I got because I don't have like a big screen TV to show for it or anything, but you buy things you think are necessities, like tires, things that you're just not extreme items, but just day to day. My engine went on my car, and I still owed on the car, so it's either let it sit there or get money. So I charged it to get the engine fixed. That was a pretty good chunk of money. But I love the car. It's a Cadillac. The thing just floated down the road. You had a big pothole, you wouldn't even feel it. Yeah, it's amazing. I was paying $500, I think, interest each month. It'd be like $1 or $2 on principal. So it take me 300 or 400 years to finally pay off that credit card. So she got us out of debt. Okay, number 18. It says continuous, so I know which one to use. Given interest is being compounded continuously in the amount of 6,000. So A is 6,000. Beginning amount of 5,500, so P is 5,500. Rate is 7.2%. R is 0.072. Find time. Interesting enough, I haven't matured any financially. I'm still the idiot I was way back when. I went and bought 2 cars this last summer. A Honda, a 2017 Honda Sport, and then I also bought a 2005 Buick Century. Love the Buick Century, but when they were filling out all the paperwork, has anybody bought a car recently? Yeah, all the paperwork they have you fill out is just unreal, isn't it? They have you sign like 30 documents type of deal. I have no clue what I was signing. I never read any of it. I just would say sign here, sign here, sign here. It's just like I could have been signing up for a 50-year loan as far as I knew. So. But we were down there, I think 3 hours total. It was unreal how long we were down there. Okay, so that's all the given information. So this would be like we want $6,000 at the end. We're going to put 5,500 in and not put any money in after that. And we're going to let it accumulate. R is 0.072. And we're wondering how long do we have to leave it in there to get $6,000? We may do a more practical example in this one. I'll come back and do another one. Okay, so this is an exponential equation because we got a variable in the exponent. So we want to get the part of the variable in the exponent by itself. That's step 1. So we'll divide both sides by 5,500. I can simplify that on the right side if I want, but it isn't necessary because we're going to plug in the calculator eventually anyway. Take natural log of both sides. So I got natural log 6,000 over 5,500 equals natural log of e to the 0.072t. Now our next step said use properties of log to get the variable out of the exponent. Natural log and e will cancel each other away, if you remember. So we've got natural log of 6,000 over 5,500 is equal to 0.072t. Divide both sides by 0.072. Natural log of 6,000 over 5,500 divided by 0.072. That's going to give us our time. So natural log 6,000 divided by 5,500 divided by 0.0772. And we have 1.21 years. I really have one dream left before I kick the bucket. And I want to buy a Ford Pinto. I think this is the site I go to. Why they ruin these by putting like big wheels on them and everything? I don't know. Not sure if I'm crazy about red, but I'd like it maybe green. But I was just looking for roughly the price. So 9,900. Let's see. That's probably the kind that I can't afford. Let's have a toad. There's a green one. That's the one I want. 11,900. Okay. So if I come back to here and go back. I want to end up with, and unless I'm going to fly out there, they probably have to ship it. So throw maybe a couple thousand more in there. I'm just guessing. Say $14,000. By the way, does anybody know why these are so rare, Pintos? One reason is they explode when you hit them from the back. It's poorly designed. So if they had rear end collisions, they'd blow up. That's where they put the gas tank. So that was always the humorous part of it is that most of them are on the road because they blew up. Also, they weren't like a fancy car or anything. Anyway, but used to drive one of those. The last car I could work on the engine. Had like an engine like a lawnmowers. So I could change the points, I could do timing. I mean, it was just fantastic. Now they got everything so computerized. I open it up and I don't even know where to look. Can't even fit my fat little hands down in there. My dad's truck, I used to be I could sit in with the engine and change the spark plugs and so forth. That's how much space was in those old vehicles. Okay, but I probably got $1,000 I could put into an account. I can spare right now. In terms of my own fund money, not money that my wife controls. I don't know. Lucky, maybe I get 2%. So the question would be, how long do I have to wait before I can buy my Ford Pinto? Okay, so I put 14,000 in for A, 1,000 in for my principal, E to the 0.02t. Divide both sides by 1,000. I get rid of these zeros here. That just becomes 14 on this side. Take natural log of both sides. Natural log and E are going to cancel. And I got natural log of 14 is equal to 0.02t. Divide both sides by 0.02. Looks like I'll have to wait 132 years. I'm probably not going to get my car, am I? Unless I save it in other ways. But putting money in and having it accumulate takes a while to get up to that amount. Now, if I put money in every month, it'd be different. You know, again, that's a different ball game altogether. Okay, let's take a look at number 19. Blah, 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 continuous. That tells me the PERT formula. Given interest has been compounded continuously, ending amount is 7,000. So A is 7,000. Beginning amount is 5,000. So P is 5,000. Time is 30 years. T is 30. Find a rate. So I want to solve for R. Okay, so we got 7,000 equals 5,000 E. R we're trying to find. T is 30, so I got 30R. This is, again, an exponential equation, so we want to get the part of the variable and the exponent by itself, so we divide both sides by 5,000. Now those zeros would cancel, and then I'll take ln of both sides, so I got natural log of 7/5 equals natural log of e to the 30R. Now again, natural log and e cancel, so that gives us 30R equals natural log of 7/5. Divide both sides by 30. And this will give us R in decimal form. So a natural log of 7 divided by 5 divided by 30. 0.0112, so forth. Again, to change it to percent, you move your decimal point 2 places to the right, or multiply by 100. Then that'd be 1.12%. Okay, number 20 says continuous, so I need my PERT formula. Let's write down what they give us. Given interest being compounded continuously, beginning amount was 2,000, so P is 2,000. Rate is 4.1%, so R is 0.041. Find out how long it'll take the money to double. I'm going to do the setup on this one, but I'm not going to continue it. A lot of people think they don't give you enough information because they say, how long will it take to double? Well, if this is my ending amount and this is my beginning amount, double my beginning amount will be 2 times P. And actually, you don't even need the principal when you're figuring this, because if I divide both sides by P now, you get 2 equals e to the RT power. So the amount of time it takes to double has nothing to do with the amount of money you put in. Okay, so let's plug in what we're given. And then I won't finish it after that because I think it'll be obvious. we get this. This is an exponential equation. We take natural log of both sides and solve it from there. Their formula, if you're going into business, doubling time, doubling rate, doubling something, I forget what it's called exactly. But you take natural log of 2 divided by r. And that'll tell you how long it'll take to double. Triple, you do natural log of 3 over r, and so forth. So that's a famous formula in business. So they don't have to sit there and do the mathematics over and over. Because they oftentimes get a question like that. Well, how long will it be before I double my money? People want to double their money for some reason. Questions, any of that? Well, we're done with that section. I'm not going to go on to 5.1 today. I'll put the test out there. This week, we're covering sections 4, 5, and 5.1. So next time we'll go into 5.1. I don't want to finish the material too early in the course. So I got to space it out accordingly. We'll probably do 5.1 and maybe a little bit of 5.2 because I'll show just some by hand of 5.2 just so I don't finish the, like I say, material too early. If you're struggling with anything from this chapter, use this time at the end to your advantage. I know, especially with COVID-19, a lot of people were attending class remotely. Don't have the same opportunity to get that one-on-one help. So again, if you need it, stick around and I'll answer whatever questions you have. But otherwise, we're done. We are getting the point pretty soon here. Where's it at? I thought it was on here. Last data drop is coming up pretty fast. I guess they don't put it up here on here anymore. But I think it's like maybe next week or the week after. So if you're doing poorly in the class and you take chapter 4 test and you're still doing real poorly, you don't think you can pull it out, then and you don't want a bad grade on your transcript, then you need to consider that. You need to talk to your advisor to see what that means. If you're a full-time student, so forth. A lot of you are high schools, so I know that, but not everybody is. Not that you're doing bad or anything, but just things for you to consider. We're done.